The technique can predict a person's ancestry and physical traits without the need for a match with an existing sample in a database. ANDAMP X200B. Australia. When a man washed up on the shores of Christmas Island in 1942. Lifeless and hunched over in a shrapnel-riddled raft. No one knew who he was. It wasn't until the 1990s that the Royal Australian Navy began to suspect that he may have been a sailor from the HMAS Sydney II, an Australian warship whose 645-member crew disappeared at sea when it sank off the coast of Western Australia during World War II. In 2006, the man's remains were exhumed, but DNA extracted from his teeth yielded no match with a list of people Navy officials thought might be his descendants. With few leads, the scientist who conducted the DNA test, Jeremy Austin, told the Navy about an emerging technique that could predict a person's ancestry and physical traits from genetic material. DNA tool. The method, known as *DNA phenotyping, * relies on variations in the genome associated with traits connected to physical appearance to assess the likelihood that a person has a certain hair, eye or skin color, among other characteristics. It differs from older techniques in that it does not require DNA to be matched with an existing sample in a database. The new tool is primarily used by police departments around the world to help identify suspects in cases where there are no witnesses. That has raised concerns about the potential for racial profiling. In Australia, forensic scientists are repurposing the technique to help link missing persons with unidentified remains in the hope of resolving long-running mysteries. In the case of the sailor, Dr. Austin sent the sample to researchers in Europe, who reported back that the man was of European ancestry and most likely had red hair and blue eyes. That alone wasn't enough to identify the sailor, but it narrowed the search. In a ship full of 645 white guys, you wouldn't expect to see more than 2 or 3 with this pigmentation, said Dr. Austin, Deputy Director of the Australian Centre for Ancient DNA at the University of Adelaide. In Australia, there are thousands of long-term unsolved missing persons cases, along with hundreds of unidentified remains held in police custody across the country. The Australian Federal Police's National DNA Programme for Unidentified and Missing Persons, launched in July 2020, is applying a suite of techniques to help law enforcement find potential links between the remains and missing persons, including DNA phenotyping. ANDAMP X200B. This forensic tool, which has been slowly advancing since the mid-2000s, is similar to genetic tests that estimate risks for certain diseases. About 5 years ago, scientists with the Australian Federal Police began developing their own version of the technology, which combines genomics, big data and machine learning. It became available for use last year. The predictions from DNA phenotyping, whether a person had, say, brown hair and blue eyes, will be brought to life by a forensic artist, combining the phenotype information with renderings of bone structure to generate a 3-dimensional digital facial reconstruction. It's an investigative lead we've never had before, said Jodie Ward, the director of the new program. Her lab, located in Canberra, the capital, will begin offering this service to police departments across the country later this year. For now, she and her team are fine-tuning the technique by testing it on DNA samples taken from remains of people who have donated their bodies to science. Soon, The technology could also include predictions about age, body mass index and height, as well as certain facial features like lip fullness and cheek structure. While Dr. Ward's focus is missing persons cases, DNA phenotyping technology will also be used by the Australian Federal Police to aid criminal investigations. In the United States, police departments have for years been using private DNA phenotyping services, like one from the Virginia-based Parabon Nanolabs, to try to generate facial images of suspects. The images are sometimes distributed to the public to assist in investigations. Many scientists, however, are skeptical of this application of the technology. "You cannot do a full facial prediction right now," said Susan Walsh, a professor of biology at Indiana University Purdue University Indianapolis who developed some of the earliest phenotyping methods for eye and hair color. "The foundation of the genetics is absolutely not there." Facial image prediction has been condemned by human rights organizations, including the ACLU, which suggest that it risks being skewed by existing social prejudices. One such episode played out in Germany in 2007. When DNA phenotyping predicted that a sample taken from a crime scene involving the murder of a police officer belonged to a woman of Eastern European ancestry. The same DNA was then linked to dozens of serious crimes across Western Europe, prompting a theory that the perpetrator was a serial offender from a traveling Roma community. It turned out that the recurring genetic material belonged to a female Polish factory worker who had accidentally contaminated the cotton swabs used to collect the samples. Similar concerns have been raised about DNA phenotyping in Australia, where some populations, particularly Indigenous Australians, are arrested and jailed at disproportionately high rates. Gabrielle Samuel, a sociologist at King's College London, said that DNA phenotyping will ultimately reflect the biases of the climate in which it is used. But Dr. Ward, the director of the new program at the Australian Federal Police, said that using DNA phenotyping on unidentified remains did not raise the same ethical questions. Because the people are deceased and because the cases are about missing persons, not crimes. The families want any and all techniques applied to these cases if it's going to help answer the question of what happened, she said. Dr. Ward said she did not see DNA phenotyping as a silver bullet for solving long-term missing persons cases. She and her team will also make use of more traditional methods, like skeletal analysis, dental record searches and radiocarbon dating. "One forensic technique is not going to give us the critical bit of information," she said. Mystery Sailor case. Such was the case with the Mystery Sailor. After his genotype was sequenced and his phenotype predicted, a team of scientists across several Australian institutions, including Dr. Ward's program, used this information to track down a woman they believed to be a living relative of the soldier. They checked her DNA and had a match. His name was Thomas Welsby Clark, the son of wealthy sheep ranchers and a descendant of Scottish immigrants. He had been a sailor on the ill-fated warship, and most likely escaped the burning vessel in a raft before dying at sea. A photograph of Mr. Clark was found, and Navy technicians had it colorized. They gave him shining blue eyes and red hair. And AMP. #X200B. New York Times.